Rails is a Rack application. All Rack applications implement a standard interface. This allows Rack-compliant app servers to serve many different Rack apps without having to be configured separately for each one. So long as the application is a Ruby object that implements a method named call and returns a specifically formatted array, it can be served by any Rack-compliant server, such as Puma or WebRick. Let's write an example Rack application to see how this is implemented. We're going to need something that will respond to a method named call. This could be a proc, a lambda, or in this case, we'll define a class that implements this method. When the app server calls our class's call method, it will pass in a hash containing information about the request. This is known as the Rack environment. Let's loop through this hash and see what is passed to us. I'm going to write a config.ru file so we can run the app. If you've done any work with Sinatra, you've probably come across this before. If not, it just tells our app server what app to run. Well, it racks up successfully. I'm using Puma as my app server here, but you might be running something else, like WebRick. But so long as it's a Rack-compliant app server, it will still run our app. We can see the server is listening for requests on port 9292. So let's visit localhost port 9292 in the browser and see what our Rack app generates. Though it racks up alright, making a request to this app raises an error, as we're not returning an array, which is what the Rack server expects. We can ignore this error for now, and instead, let's have a look at what the environment hash we printed out contains. We can see this hash gives us information on the request method, the request path, the request IP address, and various HTTP headers such as the accept language header, the user agent header, which is information on the device used to make the request, and cookies. If you're not familiar with the request headers, I would highly recommend reading the Wikipedia page list of HTTP header fields, as you'll work with them a lot as a web developer. Headers aren't a particularly tricky concept, and thinking of them as a hash that contains information about the request is a decent mental model to use. Anyway, let's get back to our Rack app and see if we can return something to the client that's a little more friendly than an error page. I'll remove this loop as we no longer need it. Instead, we're going to return something our Rack-compliant app server can understand. We're going to return a 3-element array, the first element of which will be the HTTP response status code. Status codes are just an integer that indicates to the client how the request was handled by the server. We're going to return a 200 status code that indicates that the request completed successfully. Other status codes you may have seen before are 404, which indicates the requested resource could not be found, or maybe 500, which indicates an error has occurred. If you're not familiar with status codes, the Wikipedia page list of HTTP status codes provides a useful reference, and it's well worth your time getting a general idea of the different codes. You don't need to memorize them all, but you'll be seeing a lot more of them in your first year as a web developer. The next element in the array we return is a hash containing the response HTTP headers. As well as the client sending HTTP headers to the server will also send response headers back to the client. We're just going to set the response content type header to indicate to the client that the response body is going to contain HTML. Finally, the last element in the response array is another array that contains a string. This string will be the response body. In this case, we're going to return a string of HTML, but this string could also be JSON or XML. We now have all the parts we need to send an HTTP response back to the client. We've been using the term HTTP a lot without explicitly defining what it is. HTTP stands for Hypertext Transfer Protocol. This is an agreed upon format for exchanging hypertext data between computers over a network. It's not much use me sending you data if you don't know how to understand it, so a standardized format for this has been agreed upon. Now, data can be exchanged by all computers that implement this protocol without having to reinvent the wheel every time two new computers want to communicate. How data is transferred between computers and the different protocols that exist beneath HTTP is a very large topic and out of the scope for this video. But you might have noticed this idea isn't too dissimilar to the idea of Rack. which allows many Ruby applications to work with many different app servers as they all share an agreed method of communication. By interacting with a standard interface, one application can be replaced for another without needing to make changes in the applications that call it. Keep this idea in mind when writing your own code. By encapsulating implementation details and presenting a consistent interface to the outside world, you will find your code is a lot easier to reason about and maintain. Anyway, let's make another request to our rack application and see if it now responds correctly. We've just written a simple rack compliant application. As this app is just regular Ruby and nothing magical is going on, you should be able to see how we could build up more interesting applications. One of the great side effects of rack applications, all implementing a standard interface, is that we can easily chain different rack applications together. Let's write a simple logging app that just loops through the request environment as before, and then passes off the responsibility for generating a response to some other application. So long as this other application responds to call and returns a correctly formatted response array, then everything should still work, without the logger application needing to be concerned with the implementation of exactly how this response is generated. This means we could swap the example app for some other arbitrary application so long as it implemented the same application programming interface, or API. Visiting localhost 9292 again returns us the same HTML, but now in the console we have the headers printed out. Rails uses a similar idea of chaining rack applications together to build its middleware stack. In fact, a Rails controller is actually a full rack application on its own. That's probably enough on rack for now. As a new developer, you'll likely only need a general understanding that rack exists and different rack applications can be chained together, each doing a specific job. Becoming familiar with HTTP status codes and headers, however, will be much more important in the first year of your career.